My name is Brenna Buuck. I've been a data engineer for about 10 years, working on pipeline, building data lakes, populating databases. And for those of you who don't know who MinIO is, it's distributed open source object storage software. It's a drop-in replacement for Amazon S3, but you can deploy on-prem, on colos, on data centers, on edge. It's a 100 megabyte file, so it can go in CCTV cameras or sensors on oil rigs, anywhere where your data lives. And he's joking about you all knowing who we are because we have hit 1.5 billion Docker polls, which is a major achievement if you consider we're object storage software. So today I'm going to be talking to you guys about, we probably all know, the challenges of traditional databases, their workloads, and then why you are hearing so much in this conference and probably all over about the disaggregation of storage and compute, sometimes called the unbundling of storage and compute. So I'm sure you've heard people here from DuckDB and other companies mention this, and you're probably wondering how are you going to bring this information of this trend back into your own stack. So I'm going to give you 2 modern strategies for implementing that in 15 minutes as best I can. All right, so let's talk about what we can all agree on, that traditional databases are challenging. They're often very complex, which means the insights that you can derive from these very complex infrastructures are really consolidated in the hands of a few people in your company, and that can often mean really long open recs, difficult to hire, difficult to keep, difficult to maintain. They're often fragmented, so sales might have their own database, marketing might have another, customer service might have a different one, and you're baking in silos into your infrastructure when this happens, and it happens all the time, at least in my experience. They're also fairly monolithic, and by that I mean 2 things. One, that you're usually stuck in a vendor ecosystem, so you have to purchase product in that ecosystem, even if it's not appropriate, even if it's outdated, or it doesn't work with the rest of your stack. But also, I mean that the storage and compute are very often tightly coupled. And that sort of brings me to the next thing, which means they're unscalable because of this tight coupling. It's usually very difficult to scale one without the other, which means you can't closely match to your workloads. You end up spending a lot of money. And all of these reasons and problems and challenges really draw down to one thing, which is traditional databases were built before the cloud. You can't slap the cloud on a database and have it operate as if it were a cloud-based software. That's not how it works. And so all these challenges are the reasons why databases aren't working out for people. They're expensive. This is why you're spending a lot of time fixing your data sets, why you have open data engineering tickets that are months and weeks long. This is why they're very expensive, and why you're having problems scaling up with the volume of data that you're getting. And no one's ever said the amount of data that I had is less than yesterday, right? So we're always growing, and it's going to be very difficult to scale up with this type of database infrastructure or data infrastructure, full stop. So what's the solution? And there's been plenty of vendors during this conference, and probably many others that you've been hearing talking about the solution, which is the unbundling or disaggregation of storage and compute, which allows you to pick best of breed products for each one and scale them independently to your own needs. All right, so primarily this means object storage as primary storage for databases. The traditional relationship between databases and object storage has been backups, restore, and that's still a valid use case. But with the advent of performant object storage comes the throughputs for object storage as primary storage for databases, which is the exciting thing I'm talking to you guys about. And of course, the use case for AI ML workloads has always been in object storage. Kubeflow, for example, ships with MinIO. So what does this look like on a high level? Obviously, we're talking about disaggregation of storage and compute, so you could pick the vendor appropriate for each use case. They're durable and efficient, and by that I mean they fail less often, and when they do fail, there's disaster recovery that makes sense for your business. They're multi-cloud, true multi-cloud, so you can deploy anywhere that you want to, the public clouds, your private clouds, any disks that you have, wherever you want to. And obviously, especially when we're talking about databases, their performance. So if you're not using high performant object storage, you're going to have query speeds that your customers, your internal customers or external customers, if your data is a product, are not going to be happy with. So performance is a must. So how do you do that? I think we can all agree that there's challenges. This is an interesting solution. And like I said, there's been 3 or 4 other speakers who have mentioned the same thing. But how do you bring this back into your own stack? How do you take what you've learned here back to your company? And there's 2 ways to do it. So the first way is to choose a really high performant query engine, some of which are here. So Trino, StarRocks, Dremio, and then you sit those on top of open table formats. And the reason this has become even more appealing is in part because of the announcement by OneHouse during Kyle's talk yesterday about Xtable, which allows you to use all of them. Instead of just being locked into one or the other, right? So you can use all 3, change the metadata and store it. So this is a very appealing model option. Right? And of course, you're sitting on top of object storage as your primary storage for your data lake. You made a data lake house. And there's some, I'm not going to read this whole slide because it'll be available after, and I only have 15 minutes. But I really want to point out this raw bucket here because with traditional database workloads, we're talking about what data we choose to store. It's often aggregated, cleaned, or optimized data that ends up in our warehouse. And the problem with that approach for a modern data strategy is that you miss out on data, right? Your data has an immense value to your organization, and you shouldn't leave it behind. You should store everything you have. Right? Put it in raw in your data lake and have it available to you when and if you need it. A point I already mentioned that it's possible, you don't have to pick and choose now which open table format that you like with the advent of Xtable, which I think is really cool. But there is cost and benefits to choosing open table formats. This is just a couple. There's obviously any modern open object storage will be able to handle whatever kind of file types you have, whether or not that's Parquet or any of the open table formats or like LanceDB or Arrow that many of you have been hearing about or are using. But when you use an open table format, you get the benefits like time traveling, which is also only possible if you have data to travel back to. You get ACID transactions and things like schema enforcement, which are pretty cool. But if you're worried about query performance, which is an issue, especially if your latency or like a physical distance is part of your infrastructure, then you might want to choose Parquet for speed and compression. But that also has its own downside. So whichever one you'd use, your modern stack should look something like this. You also need to implement a semantic layer, usually a catalog. The open table formats have some really cool ones. Obviously, your compute and your storage are separate in your stack, and you want to think about security, key management system, things like that. And my point of showing this is that you want to pick. vendor neutral, but you want to pick in your stack technologies that are open, that are performant, and can be deployed in a single Kubernetes YAML file in a couple minutes. Otherwise, it's not really part of a modern stack. I heard another speaker call it the postmodern stack, and I'm not ready for that. I don't know if you guys are, but this is the modern stack. All right, so that's one way to do it. The other way is called external tables or foreign tables if you're a Postgres fork. Snowflake, SQL Server, and Teradata all announced native support for external tables in the same month, which I think is really cool and indicative of this trend. So external tables allow you to query data in open storage as if it were a table in your database without movement or migration, and it acts like a materialized view or a federalized view if you're interested in that flavor of SQL. But it acts like a regular table. And you get tremendous security benefits from keeping your data where it lives, right, in your data lake. But those three that I mentioned, those very traditional databases with this functionality aren't the only ones. Almost every database vendor on the market today has functionality built in for external tables. So whatever you're using, you probably can implement this strategy into your own stack, which I think is pretty cool. So I've talked to you guys a little bit about what you already know, that databases are hard, they're complex, they're not cloud native. I let you guys know a little bit more about what the disaggregation of storage compute really means. And then I gave you two ways to do it. One is like building a whole data lakehouse essentially from scratch, which is a cool option, but also to bring external tables and object storage and disaggregation of storage compute to the traditional database workloads that many of you already have and use. So, thank you.